Hello everybody, welcome to my extremely messy desk, where today I'd like to show you some of the stuff I'm doing with baffle designs for rockets. I've used baffle designs in the ODR rocket, the Open Development Rocket, which is open source and has flown a few times. It was in Hackspace magazine, etc. And this is the type of baffle system that I created for that rocket. And then here's another one that I've made out of aluminium that's for another build, which I'll talk about in a minute. But it's fair to say that the majority of high power rockets don't use baffle systems, and that's because the more common way to baffle systems can be used for two things. They can be used to help you make a strong anchor point for the recovery systems, which is all the webbing and the stuff that attaches to the parachutes or the streamers that help slow the rocket down as it comes back down to Earth. So they can be used to create those mounting points, or they can be used to create a sort of baffle that stops the hot gases from the motor ejection charges from damaging components above, but you might not include the recovery mount point on the actual baffle as well. So they can kind of serve two functions, one about kind of safeguarding from kind of fire, and the other one is as to provide a structural point for the recovery. More commonly for structural points for recovery, if this was like a 29mm motor mount tube, but it was going inside a 76mm airframe, this is the centering ring that would be glued to both tubes, and there'd be a couple of them, maybe even three, and you can see that you've got loads of room here to drill a hole and to mount a nice lifting eye as a secure kind of recovery system mount point. You've got loads of space to do that. The challenge arises either when you're building something minimum diameter. So for example, if I was building this up as a minimum diameter rocket, so it takes a 29mm motor directly, then there is no centering ring for me to mount that recovery mount to. So this is not very nicely made. It was made in a bit of a rush, but it did used to be old beer cans. So yeah, it's a bit of aluminium. And it's going to get epoxied inside a motor. There's plenty of clearance, and the bad knurl is to kind of provide some key surface for more contact area for the epoxy to sit between that and the tube. So this will get glued in inside the tube, and it's got this lifting eye kind of bolted through it, so it's going to be a really secure point to add a recovery system to. This one is just hollow, and it has 4 holes. The 4 holes obviously still allow the recovery gases ejected by the motor to push through and to push out the recovery system. It will probably be a dual deploy system, and the motor recovery will just be used as a backup, but still it's important that those gases get through. It doesn't particularly protect the recovery system from the hot gases, this one, because it has no baffle plates inside it. So whilst it creates a really secure mount point, it's not particularly protecting the recovery from the flames. The reason is that in this rocket I'm probably going to use Kevlar, and I'm going to do the Burrito wrap method, which is where you wrap the parachute up in a small sort of handkerchief's worth of Nomex fireproof cloth. Okay, back to this one. We'll cut away now to my laptop. I've got a bit of CAD of what's going on inside here. So this is a coupler tube, a piece of coupler tube that's about 60mm in length, and you can see that, and so it would slide inside a 54mm tube. The ODR rocket, for example, uses a 38mm motor mount, so by the time you've put a 38mm motor tube in to a 54mm airframe, you've only got like 6 or 7mm of centering ring. So again, there isn't enough room to mount the recovery eye bolt to it. So the recovery eye bolt goes all through the center holes of these baffle plates, which are all glued inside this short length of coupler tube, and you can see hopefully that there are 4 plates inside, and they all have the same sort of size holes going through them, but they've all been mounted at slight different angles, so that there is no direct hole all the way through the baffle. So hot gases travelling through, if we move back to here, hot gases travelling through can't travel directly through. So that cools the gases down a little bit as they make their journey through, but it also means any hot sparks or any hot debris going through here is going to hit the internal panels and not come through as a hot burning spark that could theoretically burn into your recovery system. The recovery system for this is not particularly fireproof, but it's this ex-army parachute webbing that I use this not because it's best, but because I bought a vast amount of it for very little money. So underneath this covering cloth there's some of this that's been stitched in a loop. Not the neatest stitching on this bit, this was just a test piece, but very, very strong. So stitched into a loop through the lifting eye, and then I've covered the lifting eye with Nomex. So I've stitched a thin tube of Nomex together. I left a little bit to cover up this end bit, and basically that's some fire retardant cloth that this tube extends about 30 centimeters up the main piece of webbing, and just again will just sort of make it a little bit more resistant to fireproof. So yeah, that's how we're doing the baffles on the ODR rocket and on some of the other stuff. It's mainly the baffle plates are made out of plywood. The end plates are thicker, so internally the baffle plates are 3mm ply, give it a coat of epoxy resin to make them a bit more fireproof. The end plates, these sort of more bulkhead ones, are more structural, so they're 8mm of ply with 2mm of G10 that's been keyed all'epoxide goloff under pressure. So we've got fiberglass and the plywood there, and I use a bolt that goes all the way through the system, so a 65mm lifting eye all the way through, which is nice and strong. And also, although it'd be a pain in the backside, it means that you could theoretically remove this even if it's Loctited up. You could remove it with a long socket extension through the motor mount tube. There we go. Any questions, do feel free to ask, and thanks for watching. Ta-ta!